All right, let's talk about Apache JMeter. Today, we're not just going to click through some buttons. Nope. We're going to build a real performance test from the ground up. And I'm going to explain the why behind every single step. So let's get into it.
You know, every developer, every product manager has had that little voice in the back of their head after a big launch. Will this thing actually hold up when people start using it? It's a huge deal, and it can totally make or break your user's experience. So picture this. You just launched a brand new, shiny login feature. It works perfectly when you test it, but what happens when 100 people try to log in at the same time? Or 1,000? Is your app going to handle that load gracefully, or is it just going to fall over? Well, the answer to that question is something called performance testing. See, this isn't about if a feature works. We already know it does. It's about how well it works when the pressure is on. We're talking about speed, stability, scalability. It's really about finding the breaking point before your users do. And this is exactly where Apache JMeter comes into the picture. It's this fantastic, free, open source tool that lets you simulate a virtual mob, a whole crowd of users, to see how your application really performs under stress. Okay, so we've got our tool. The very first thing we need to do is build our virtual crowd. We have to tell JMeter exactly how many users to pretend to be and what we want them to do. Now, in the world of JMeter, this virtual crowd is managed by something called a thread group. It's basically the command center for our test. You can think of each thread as a single virtual user. So the thread group is where you define the size of your testing squad and their overall game plan. So let's take a look at how we're setting up our squad for this demo. As you can see, we're setting the number of threads to 10. That means 10 virtual users. Then you've got the ramp-up period, which we've set to 10 seconds. This just means JMeter won't throw all 10 users at the app at once. It's going to add one new user every second, which is a bit more realistic. And finally, the loop count is just one, so each user will run through the test exactly one time. We're keeping it simple. All right, we've got our 10 virtual users all lined up and ready to go. But what are they supposed to do? We need to give them a mission. And their mission is simple: log in. We define this using what's called an HTTP request sampler. This is where we tell JMeter the specifics. We set the server name to our target website. We choose the post method because we're sending data, a username and password, and we define the exact path, which is /login. This is pretty much the digital version of a user typing in an address and hitting enter. And this right here, this is the actual data our virtual users will send. It's a little piece of JSON that contains the username and password they're going to use to log in. But hold on, we're not quite done. There's one more crucial detail. We've told JMeter what data to send, but we haven't told the server what kind of data it's about to receive. Is it plain text? Is it JSON? The server needs to know what to expect. So we have to add a header. We use an HTTP header manager to add a content type header with the value application/JSON. This is basically like putting a label on a package that says, hey, this box contains JSON. Seriously, without this, a lot of modern APIs will just reject the request outright. Okay, our test plan is just about ready. Our users have their mission. Now we need a way to actually watch the test and see what happens. In JMeter, we do this with things called listeners. We're going to add two essential listeners here. The first is the view results tree. Think of this as your detective. It shows you every single request and response in detail, which is perfect for debugging and just making sure your script is working correctly. Then there's a summary report. This is your analyst. It takes all that raw data and boils it down into the high-level performance numbers that we actually care about. So our test is built, our monitors are in place. You know what that means. It's time to run this thing and see what the results tell us. So we hit that green start button. JMeter sends our 10 users on their way, 1 per second, to hit that login endpoint. After just a few moments, the test is done, and now we turn our attention to the summary report to analyze the results. The first key metric we look at is throughput. This tells us how many requests per second our server was able to handle. Think of it as the server's productivity rate. A higher throughput number is generally a good thing. It means your application is more scalable. Next up, we have the average response time, which is measured in milliseconds. This is how long, on average, it took for the server to respond to each user's login request. This is a direct measure of the user experience. You always want this number to be as low as possible. Nobody likes a slow website. And finally, maybe the most critical metric of them all, the error percentage. This shows what percentage of our 10 requests flat out failed. Ideally, for a healthy application, this number should always be 0. Any errors here are a huge red flag that something broke under the load. And that's it. You've just learned how to build and interpret a real performance test. You now have the fundamental skills to create a test plan, simulate a crowd of users, and analyze the results to make sure your application is actually ready for the real world. So what's next? You have the tools now, you have the knowledge. So what's the first thing you're going to test in your own application? What's that one critical feature you need to be sure about? The answers to those questions, well, they could be the key to building